Hello and welcome to session 220 in the AIsafety.com reading group. Tonight we have June Koo with us, presenting her work on MetaEthical.AI. She describes herself as as a computational meta-ethicist, and as far as I can Google, she's the only person in the world with that title. So, June, thank you for coming.
I appreciate everyone coming here. And so today I'm going to introduce my research on MetaEthical.AI, and it's basically a technical proposal for how to compute an ethical goal function that would be suitable for like a smarter than human artificial intelligence, or in slogan form, how to get an AI that does what we should want it to do. So my approach here is to basically directly tackle some key philosophical problems, including metaethics, and then the problem of intentionality or mental content, and that's broken into two sections: first the semantics, and then first the syntax, and then the semantics. So what is metaethics? Well, ethics is about what to do. Metaethics is kind of a layer more abstract than that. It asks things like, what is the meaning of ethical concepts? And what is the status and metaphysics of ethical facts? So for instance, are ethical statements the sorts of things that can be true or false? And if so, what in the world would make it true or false? So I think maybe a good intro to metaethics is, imagine that you're translating some foreign language, and you want to know what, if anything, you should translate into the concept should. One thing you don't want to do is just immediately jump to your ethical theory as an analytic truth. So for instance, maybe you're a utilitarian in your ethical theory. I think you still shouldn't think that should is just synonymous with happiness maximizing. Because then you're going to run into issues if someone says some people should suffer in hell, then it seems like you're going to have to attribute to them this incoherent thought that suffering in hell somehow maximizes happiness, when they want to just be retributivist about it. So if you think of all the different things that people have held to be ethical or not, and do so, and somewhat coherently, we know what they mean, even if we disagree with them, then I think that starts suggesting that the actual content of the ethical theory is not that central to the meaning. Instead, I would look at the inferential roles or conceptual intuition surrounding the concept of should. So for instance, generally, if I'm judging that I should do something, that usually comes along with motivation to do it. If you're translating me as saying I should do something and that never has any tie to my motivations, you might start questioning whether you got the right translation. So similarly, I think it at least purports to be factual. We assert or deny ethical statements. We argue for or against them. We can wonder and inquire into what we should do. And when we're saying that someone should do something, then there certainly is a sense in which we're trying to influence their behavior, but it's not just any old type of influence. So we're not just trying to manipulate or brainwash them. Instead, it seems like we're trying to get them to recognize reasons that they should do it. So I think if they should do something, then generally they should be able to correctly reason from it, from something that they already accept. I think talking about what we should do invites this kind of open-ended reflection. If I say you should do X because of Y, then we can ask in turn, well, okay, but should I do Y? And it kind of always makes sense to ask that question. And finally, I think there's deliberating about what to do seems to not just tend to come along with our motivation, not just correlation, but I would argue this should actually be at least a causal tendency, so that deliberation isn't just this epiphenomenal thing that has no causal effect on anything. So I think what this stuff starts pointing to is that ethics presupposes a philosophy of action or some kind of normative psychology. And you might notice that in general, ethics seems to only apply to agents and usually human beings, adult human beings, and not to other animals. Instead, it seems to be restricted to agents who have some capacity to reflect on their desires. And when they're reflecting on their desires, they're assessing them according to some sort of standard, and that assessment exerts some causal control over their desires. And then similarly, for any given standard, we could assess them according to some other standard, and that similarly exerts control over those standards. And so I model all of this with positing higher order preferences or utility functions. So these are things that are going to be mathematically isomorphic to normal utility functions. But instead of governing actions, they're going to govern other preferences through normative judgments. So this leads to the statement of my metaethics, which I call norm descriptivism, which is that ethics reduces to which values best satisfy these higher order decision criteria. Decision criteria I just kind of use synonymously with the higher order preferences utility functions. And so my argument for this would be that this is the best way of systematizing and explaining the conceptual intuitions from the previous slide. And on this view, ethical facts just turn out to be the correct answers to the questions that we're asking in deliberation about what to do. So I guess to go from the metaethics to the ethics, I guess you would want to figure out what are these questions that we're asking in deliberation. And my approach to that is just to give a general theory of what mental representations, whether it's a belief or a goal, is also counting as a mental representation. I'll give a general account of how mental representations work, and then that would fill in the content of these deliberative questions and therefore of ethics. So philosophers call this the problem of intentionality. The problem of intentionality asks things like, what are mental representations and what determines their content? In this first section, we're going to start with just determining the logical form of an agent's representation. And so my answer borrows a lot from Daniel Dennett and his intentional strategy. So here's a quote from him saying, what it is to be a genuine believer is to be an intentional system, a system whose behavior is reliably and voluminously predictable via the intentional strategy. So as far as I know, Dennett doesn't get into how you might work this out in technical detail. So that's what I've been working on. So I'm going to define the sort of space of intentional strategies or decision algorithms. Just mathematically, what does this space look like? Well, a lot of it is going to be pretty familiar from standard decision theory. You're going to have credences, which are just assigning a subjective probability from 0 to 1 to various logical causal formulas. That will include conditional probability as well. Utility functions or preferences, where you assign some real or rational number to some formula being satisfied. There's going to be the inputs and outputs. Inputs are going to be a subset of the credences that correspond to like peripheral sensory brain events, so sense data essentially. And then the outputs would be the actions governed by the decision algorithm. So just be like motor output. And all of that is fairly standard so far. But the main thing that's new is these higher order preferences or utility functions. Sometimes I call them accepted norms. And these are, again, very much like the utility functions, they're also assigning real or rational numbers to formulas. But in this case, these formulas are generally going to be referring to not the external world, but to other utility functions or preferences within the agent. So all of that defines a decision state, and then we're going to have state transitions that describe the dynamics of how an agent moves from a given state to another one based on new inputs coming in. So that just sort of tells you all the possible intentional strategies or decision algorithms that we might attribute to a brain. But given some brain, we want to pick the best one, and so we want some notion of what is the best intentional explanation. It's got a few components. So first, we're looking for one that best compresses the brain's behavior. And the compression is kind of a way of favoring the simplest and best fitting decision algorithmic explanation of the brain's transition behavior. Next, we've got some measures of rationality. So this is going to include things like probabilistic coherence, instrumental rationality, and that's going to include the equivalent of instrumental rationality for the higher order preferences. And this basically just amounts to some kind of principle of charity in interpreting what the brain is doing. If you could attribute to the brain some rational thing that it's doing and some crazy thing, then all else being equal, attribute it to a more rational thing. And then finally, we want these explanations to be ambitious. So it's trying to account for as much of the brain data as it can. Ideally, anything left over in the brain data is more just noise than it is a decision process. Okay, so far that's basically telling us what is sort of most useful model of a brain. But you might have this worry about wanting a more realist criteria as opposed to like an instrumentalist criteria. And I think Dennett himself is a little wishy-washy on how realist or instrumentalist he wants to be. But basically, I have this worry that couldn't you just be coming up with this decision algorithm as a useful predictive model, but that's not actually what the brain itself is doing. And so I add a further condition that I borrow from David Chalmers. So Chalmers has this paper on how or when a physical system implements a computation. And so in our case, the physical systems that we're going to be interested in is going to be the brain states and their causal relations to further brain states. So this is actually going to be like a Yuta-Pearl style causal model of the brain. And then I've introduced what the decision states would be and the state transitions between them. So the implementation function f is supposed to take a brain state and tell you what decision state is that brain state in. So it'll tell you the credences and utilities, preferences, things of that sort. And so the Chalmers criteria is basically this equation. We want to kind of make sure that whether we start at a given brain state and move to the next brain state caused by it, and then interpret it with f into the decision state, that this route gives you the same result as if you went this other route. First, you take that brain state, interpret it into the decision state, and then take the state transition to reach the final decision state. So we're going to require this not just for the brain states that we've actually observed, but even counterfactually in the causal model for all the possible brain states. And there's more details in his paper, Does a Rock Implement Every Finite State Automata? And Chalmers develops this theory as a way of saying, no, it doesn't, which is hopefully the intuitive result that we want. Okay, so So that covers how we would take a brain and try to figure out what formulas, the syntax that we should attribute to it. But then given the syntax, what, if anything, do these logical expressions refer to, or what are the truth conditions of the formulas? So there's a few principles that are grounding the reference in my theory. So first, we're going to have these self-denoting input expressions. So that subset of the credences, these are supposed to be the sense data, and they're going to refer to the brain states that implement credence in them. So they're kind of self-referring, that those brain states are kind of self-referring in that way. So you might think of their content as something like, this sense datum is occurring. Or if we want to make it even more simple, just a pure demonstrative this. And if we're trying to sort of build up a theory compositionally, starting from some atoms and building up molecules, then we kind of want to start with, we kind of want to try to find something that's plausible, that's very simple and primitive, and I think this is a good candidate. I think everything kind of also carries information about itself, so it's not surprising that we could have things stand in for themselves. And also this kind of makes the whole project work because these are going to serve as anchor points for logical and causal combinations of these expressions. So if you have a bunch of these sense data referring to their own brain states, then we could start talking about a conjunction of them, or positing a hidden cause that causes that conjunction of sense data, and that starts allowing us to refer to other things. Another thing grounding the reference is these inferential goals for connectives. So connectives just being things like conjunction or disjunction, causation. So imagine that you have an agent where we observe the following dispositions. When they believe the proposition P and the proposition Q, then they tend to infer this new proposition P star Q. And when they believe P star Q, then they tend to infer that P and infer that Q. So you might notice that this seems to match onto the truth table for conjunction. And so this idea comes from Ned Block in his conceptual role semantics. And the idea that the idea seems to be that we could figure out that the star operation seems to be a conjunction because the inferences that these are involved in are basically matching the axioms for conjunction. And so this can generalize to other connectives being grounded in their axioms. And so if we're going through this process of attributing the syntax, then when we attribute these connectives in a way that deviates from these axioms, these are going to be punished by the coherence score. Okay, and then finally, so those gives you some ways of building up some references, and then there's this more general idea of how to, if you already have some old terms that you understand, there's this Ramsey-Lewis, sometimes Carnett is thrown in, method for defining new terms. Originally, it was for theoretical terms, like for a scientific theory. Here we're going to just use a simple example of car theory. I think this also comes from Block. So imagine there's like a scientific theory, and it's introducing in this lavender color. It's introducing some new terms, carburetor and ignition chamber, using some old terms like fuel and air, and we're assuming that we already understand the fuel and air and other terms, but that this theory is introducing carburetor and ignition chamber. So it might say the carburetor mixes fuel and air and sends the mixture to the ignition chamber, which in turn blah blah blah. Now, one thing you might be worried about is if we're maybe defining the carburetor in terms of its interactions with the ignition chamber, and we're and we're defining the ignition chamber in terms of its interactions with the carburetor, is that going to lead to some kind of vicious circularity in definitions? It turns out that there's this nice technique that kind of shows that that's not really that big of a concern. What you do is called Rancification, and you take your theory and you replace any of the new terms with variables. So here, carburetor has become X and ignition chamber has become Y, and then you just do existential quantification over it. So now you're saying, this is called the Ranci sentence. Now you're just saying there exists some X and there exists a Y such that the X mixes fuel and air and sends the mixture to the Y, which in turn blah, blah, blah. And so there's a nice way of, if you already have the old terms, figuring out the meaning of new terms to refer to whatever fulfills the functional or causal goals posited for them. So in this case, we've done it with objects, but if you use a second order logic, this can generalize to predicates and relations as well. And so I kind of want to apply this pretty globally and holistically, but the usual way it's talked about is you have the entire theory being true, so that we have like all of the sentences are being true. But when you're moving more towards filling in all the mental representations of an agent, then probably they're going to have some false beliefs, and we'd like to still apply this method even if some of them are false. So I'm kind of weakening the condition here to allow for some error, and then we're just kind of try to find the set of beliefs that would minimize squared error, the set of interpretations, semantic interpretations of their beliefs that would minimize the squared error as we're filling in the functional causal roles. And let's see, yeah, I can go into more technical details later, but this hopefully gets you some intuitive idea of what principles I'm relying on. Okay, so to put this all together, here's basically how I propose computing friendliness in 5 steps. So first step, we're going to start with just assume that we're given in the AI a low-level causal model of the world and the adult human brains within it. Then we're going to take those brains and we're going to attribute the syntax and dynamics of mental representations to those brains. Part of that syntax is going to include for these higher order preferences what they refer to, or at least at this stage, at least their logical form, not yet what they refer to. But with the higher order decision criteria, we could iteratively apply those criteria to figure out what rational first order utility functions these brains should have. And then so far these rational utility functions are still couched in the agent's language of thought. So next up, we translate using the semantics, translate their rational utility functions from the language of thought to external world states, which would just be like the causal model that the AI has, for instance. And then now that helps make it more comparable. So now we could aggregate everyone's rational utility functions using some social choice or social welfare function. And I think that's it. Got some credit for images and if necessary, some technical details in an appendix. Maybe I'll keep it on this slide. Yeah, so appreciate any questions.
Okay, thank you very much, June, for your presentation. And so the first question will be from Stuart Armstrong.
Okay, well, thanks for this presentation. There's a lot of interesting ideas in there. So the first question is just a general meta one. Where do you see your project as needing as being the most incomplete, and where do you see it as being complete? So of these, say, 5 steps, are some of them you think basically done, or others need a lot of work, or what's your feeling on that?
Yeah. Yeah, I guess I sort of think of it as, yeah, I mean, so a lot of my background has been in academic philosophy, but then moving into software engineering. So I'm kind of taking a engineering approach to this, I suppose, and just trying to come up with what would be like a minimum viable product for computing friendliness. So, I mean, I think that I think that one thing that could be filled in more is in what areas am I kind of taking liberties with biological or psychological plausibility? I mean, so I'm not requiring agents to reason perfectly by any means. It's sort of made into a gradational coherence scale. So that's one way in which I can accommodate some psychological plausibility in there. But there might be further ways, or maybe different types of logics that would be better able to capture how humans reason. Or for instance, maybe like, I mean, right now, all of the credences are sort of in one big belief box, but maybe there's suggestions from psychology that actually there's some kind of massive modularity going on in the mind. Maybe that modularity should be explicitly represented in the model. So I think there's a category of just making it, you know, maybe there are ways in which, despite trying to accommodate more, I'm still kind of assuming that human brains are more computer-like than they actually are. So that's one big area where I can see a lot of room for improvement.
So would this be about in your first step, for example?
Yeah, well, the first step is, that's just sort of the starting point. Yeah, so I'm just assuming that these are inputs to the AI in computing this. I mean, I guess we could relax some of this stuff as well. Like, basically, if you have, instead of a single causal model that we're just assuming is an oracle telling us the truth of the world, if instead we have a probability distribution over causal models of the world, then I think a lot of this stuff should straightforwardly carry over, like conceptually at least. It should be hopefully pretty clear what would be going on.
I don't think that standard uncertainty is a problem here.
Yeah.
That's something we're quite used to dealing with.
Mm-hmm.
Would you like to do the first question, Søren?
Sure.
Other people?
So one of the things we discussed in the reading group when we read this was a path towards a feasibility, basically, both in terms of if we are actually implementing this, and also in terms of making a simple end-to-end test. Like with the software that you have already developed, would it be possible to make a world with 2 brains that want ice cream or chocolate, and then actually see the computed utility function from that?
Mm-hmm. Let's see. So right now it requires infinite computational power. And then, so that's mostly because I'm using the Kolmogorov complexity in various places, which is uncomputable. I mean, you could substitute some finite approximations to those. I think like minimum message length, minimum description length are some existing ways of having finite approximations to the Kolmogorov complexity. And then, but even once you make that finite, there's like, you know, virtually no performance optimizations whatsoever in most of my code here. So many of them are simple brute force algorithms that were more about, can we even solve this with infinite computational power, just to sort of make it clear what we're aiming at. And it would certainly take a lot of work to try to pare it down. Now I have let's see if I could right. So I have written some I do have some test coverage. So anytime on my website you see a check mark next to a procedure, then that points to a test of that procedure. So I think there was, last I checked, maybe like 47% of the procedures have some test. So maybe, yeah, it would take a while to get. I also would like to build some very simple toy model to try out this theory there. Yeah, it's going to take some work because there's just lots of places where things are very super duper exponential, and some of the testing procedures I make use of some caching and stuff just to be able to have any hope of testing this stuff. So there's maybe some engineering tricks you could do so that it doesn't actually have to compute like all possible decision algorithms that might correspond to a brain. Maybe it's enough just to like sample from that distribution. So yeah, certainly there's many places where you could start making this more computationally tractable. Yeah, and aside from a couple of places where it was useful to be able to write the tests, there hasn't been much work yet in allowing for that kind of end-to-end test. But that certainly would be a direction I am interested in going.
Okay, thank you for your answer. Stuart, would you take that?
Yeah, so one of the great advantages of the way you've laid it out as a program is that it provides clarity as to exactly what is assumed. One of the great disadvantages is that it doesn't allow us to see how big an assumption or how much work is required on one line of code versus another. Some of them may be entirely true, some of them may need a little bit of work, some of them may be hiding a whole part of the problem in. Now, this is the bit that Soren knew that I was going to bring up there on the Occam's razor result. You defined the best intentional explanation as having maximal compression. Yeah, let's get the slide up. High rationality and ambition. Well, let me give you an explanation that is absolutely fantastic on all these fronts. Humans are fully rational in every single thing that they do, and they always pick the perfect action. This is, I've shown in my result, this is, gives you the best compression. It is obviously fully rational, and the ambition is perfect. It explains everything.
Mm-hmm. Okay, so you're talking about like your no free lunch theorem. Yeah. I've been wanting to dig into that further. I haven't. I just sort of barely skimmed it, but I do wonder whether my setup is a little bit different from the one you consider, in particular because of the Chalmers criteria that has to be in place. So whenever you're attributing some decision algorithm, it's gonna require that it actually correspond with the brain's transition behavior.
That does not seem to be a problem. so the humans are fully rational. We all agree is a degenerate example. It's wrong. But we need to find out why it's wrong. And when you do that, what happens is that the utility function expands to almost the whole of the brain. So the whole of the brain can be seen as computing the utility function or the reward function. And then you can zoom in on, say, a small set of neurons, which are the input-output, and they are implementing the decision procedure, which is just basically follow what the rest of the brain has computed. So it does not seem to me that it would be that hard to designate a particular part of things as the rational decision makers, because that's a very small, defining a fully rational decision maker does not take much code, and you can basically assign it to just a few neurons that pass on the message. Basically, if you want, the rest of the brain says taking this action is the right thing to do in terms of utility. The intermediate neurons say, thank you, we will therefore take that action. And that's the rationality module. And then you seem to have a model that works in your sense.
Yeah, I think this is kind of reminiscent of like Putnam's paradox that originally motivated Chalmers in his paper. Mm-hmm. So Putnam, it was using this model of like a finite state algorithms, and there any given finite state, any given state within there, it was treated as like kind of simple. It didn't involve any internal structure. One of the moves that Chalmers makes, which I didn't really talk about in this slide, but it is in this paper, Does a Rock Implement Every Finite State Automata, is he moves to what he calls a combinatorial state algorithm, where instead of allowing the some simple state to potentially encode all of the some complex state, he wants to more explicitly model the internal structure within any given state. So within a physical system, it's going to be implemented in a bunch of substates. So I do still wonder if that is able to get around this type of objection.
I have reasons to believe that the result still applies with internals. Well, I know the result applies when you know the internals of the agent. It just depends on how many. Would you mind if I shared a paper here?
Oh, sure.
I know it's your talk. Oh, no, not a paper, a blog post.
Okay. Should I stop sharing my screen?
No, that's fine. I'll just put it in the now. Okay. Learning human preferences, black box, white box, structured white box. Essentially, the problem is not just that you have to identify how the algorithm happens inside, but what are the correct labels for the algorithm, for the different parts of the brain? Why is this bit beliefs? Is this motivation? Is this rationality? Of course, it's much more complicated in the human brain, but what are the criteria that you would use in assigning these labels to the different parts of the brain, and whether that can be done, whether that can be automated now it can be automated if you make enough assumptions, but the kind of structural assumptions that you've been talking about do not seem to be sufficient or even close to sufficient.
Okay, so the white box is going to include knowing its internal structure?
Yes.
Okay.
It's and the thing is that what we need is, well, here I call them structural assumptions, in other places I call them normative assumptions, which are, given that you know the internal structure, how are you going to assign labels to them? Now, there's a rather silly example where something is labeled tuna, but that's basically just to show the arbitrariness of the labels. And what typically happens with humans that when humans approach these problems that resembles a bit your description there, is that we define these things with very few syntactic connections, like the beliefs take input from the senses, the action selector is the bit that outputs to the moving about and stuff like that, and the beliefs go into this, and so does the preferences and so on. But those few structural assumptions, that generally there's trillions of ways of taking a complex algorithm and matching those. So there seems to need some extra amount of information, or assumptions, what I call structural assumptions. Now, it's not hopeless, but I don't want, I want to talk about your approach, not about mine. But it does seem that this is, as it stands, I would say this is a huge gap in your approach. That is just a few lines on your MetaEthics page. So just as an illustration of the potential hiding of large problems in small lines of code.
Okay, well, I look forward to, I don't think I've seen this this post before.
I've been told that I'm not the clearest communicator, and in any case, if you want to talk about that, please do let me know.
Yeah.
Should we take next question, or?
Sure.
So Jack, you had a question?
Just like sort of a clarifying question. So in your 5 steps, I think the third step is iterating higher, applying higher order decision criteria to reach rational utility functions. So for that to occur, does there need to be the assumption that humans, or whatever brains you're modeling, does there need to be the assumption that those have coherent utility functions? Because it's not immediately obvious to me that humans do have coherent utility functions, or that we should expect that to be true. And maybe it is, I just don't know.
Yeah. Let's see. So yeah, I think this might be one of the places where for the first version, I think it's probably going to end up trying to find the utility function that is closest to theirs, and that is rational, I believe. Let me think. Yeah, I mean that might be something to relax in later stages. Yeah, I'm just trying to. So, yeah, I mean, I guess the way that I've encoded the utility functions is, yeah. So if I had modeled the agents with, say, like I guess, ordinal utility functions, then there would be room to model it as irrational. But because I took a more simple approach of just modeling them with cardinal utility functions, I think that that's going to make it so that they do all have utility function. So yeah, so I am kind of interested in, can we relax those assumptions and still make the project work? And my intuition says yes. Like, for instance, maybe drop completeness, but we could still do things with the different possible ways of making them complete, and still run the algorithms off of those. But that will probably be more for future work. Yeah.
Gotcha. Okay. Thanks.
Okay.
My next question or point is, instead of pointing out something that might be unexpectedly difficult, I'm going to point out something that I think might be unexpectedly easy, in that the grounding of, to use the sort of the GoFi term, the grounding of the symbols in the brain, which I believe you are, translating syntax to semantics. This may be a lot easier than we think, because it seems that there's an empirical definition of this, which is, can we use the symbols in the brain to predict things about the outside world, or what is the relationship between the symbols in the brain and the symbols in the outside world in a large set of environments that the humans find themselves in? So
yeah, I do think that there should be a lot of fairly easy test cases there. I think I do have a little bit of a remaining worry, though, especially because the most crucial symbols to ground would be the ones that show up in the higher order preferences. So I think those higher order preferences being a little bit further removed from everyday action, I do wonder if those are going to be less amenable to that sort of treatment, and there we want maybe more of a theory that's been tested by the easy cases, but a theory guiding us in figuring out what those representations are.
well, you've touched upon a subtle issue there, which is that our symbols are well grounded by our experience in the environments that we know. The symbols that are not particularly well grounded are often ones that are not well defined. Sorry, if you place the humans or the agents in a new situation where some of their symbols don't work the same way that they're used to, one of the examples I use is, what if someone creates a species, human-like, a slave species, that want to be slaves, definitely want to be slaves, but don't enjoy being slaves. They're recognizably human, they have preferences, which is to be slaves, they have enjoyments, thing. And in this situation, a lot of, say, common assumptions that normally go together start breaking down, or splintering was the term that I was using. And this is the situation in which you generally find that these higher order symbols, or these more abstract symbols that you thought you had a good grasp on, suddenly you aren't so sure anymore, or they can be defined in multiple ways. In a way, this is what philosophers are doing all the time, because they take common concepts and push them into extreme thought experiments where they break down, but if a world with potentially super intelligent AI is a world where the AI can push the environment into incredible new states, where the philosophical thought experiments are the actual thing, do you have any way of sort of dealing with that when symbols become ambiguous, or when symbols that used to sort of be synonyms are no longer synonymous?
Yeah, so I haven't actually gone into so in my meta-ethics paper, which some of you read last week, and so far in this presentation, I actually haven't gone into that much technical detail. It turns out that I'm giving sort of a simplified view of things here. So maybe I should actually get into this appendix slide. So my first thought, and the way I sort of certainly in the meta-ethics paper had been talking, I've been assuming, I don't know if this is going to directly translate into your worries. They might still be separate, but just to give you some idea of where I actually end up with the technical specification. So in the first pass, I kind of assumed that these higher order utility functions form some kind of a neat hierarchy, right? So maybe there's just one highest order utility function, and then your job is relatively easy. Figure out what lower order utility functions that it prescribes, and then keep propagating that down until you reach the first order utility function. But I think that's not exactly psychologically plausible. I think a more realistic model would have utility functions that are maybe able to mutually influence each other with no single one on top. Mm-hmm. So in this case, I'd want to iteratively choose, sort of allowing them to simultaneously influence each other, and at each stage you're choosing outputs that best satisfy each of its decision criteria. And you keep simultaneously updating until you reach some kind of stationary equilibrium. I think even that one comes with an assumption that we might not be able to retain. And namely, it assumes that there's a network topology of which accepted norms are governing which other accepted norms or higher order utility functions. And it's possible that those actually are path dependent and dependent on what input you feed it. So I actually think we have to move to even more complicated one, where now we're going to simulate all continuations of an agent and apply a weighted social welfare function, and continuations who better satisfy those decision criteria and preserve agential identity, which is kind of like personal identity. But basically, they better satisfy the decision criteria, and there hasn't been other irrelevant changes to their values. Those continuations are going to have more weight, and then you apply a social welfare function to aggregate them. Did you want to?
These are close to the kind of thing that I have been thinking about, and so it is. I don't want to come and say, as because you're thinking similarly to me, you must be right, but it means at least that you have been thinking about the same issues and how to address it. Just to check one thing, there is no strict ordering. A weak higher order utility function can be overruled by strong lower order preferences.
Yeah, I think so. I think that should be possible.
Like say a mild religious preference on sexuality or something like that can be overruled by sort of strong object level ones, would you say, to pick an example?
Yeah. Let's see. Yeah, I think so. On that case, I'm going to end up saying something very similar. I think I'm just going to take slight issue with the way you said it. You described it as the first order preferences overriding the meta level preference. Instead, what I would say, I would probably say we want to model that as a different meta level preference that says something like when you have first order values that strongly conflict with some kind of weaker high order preference, then allow the first order to override that one. But that's all going on within this second meta level preference. So conceptually, I kind of one problem in the language here is higher order preference is ambiguous between a couple of things. So one notion of higher order preference that's not the one for the most part that I'm using is one that's a first order preference. It's a preference in the sense that it is governing actions. But it could have some higher order content. It could have content that includes talking about other preferences. So you could have a preference to change your preferences. And I think those are different from higher order preferences that are defined not by the content, but by its causal functional roles in changing your other utility functions. Because that first type of preference that really is just a first order preference governs actions and only affects other preferences through actions. And I think that when we're talking about things like being moved by moral arguments, I think we're not talking about this pragmatic route.
Okay, I'll have a follow-up question on that after the next question.
Okay, so that would be my question. One thing I didn't see, and maybe that was because I didn't read it very carefully, was an explicit comparison with ICSI. So I would like to hear your thoughts about how this relates to ICSI, and in particular, the thing that ICSI is outside the universe, and it seems possible to me that your construction also kind of assumes that the computer that's implementing this is outside the universe. Or is that a requirement?
Let's see. So all of this is supposed to be going on like within the mind of the AI. The AI is supposed to have a complete true causal model of the world and the brains in it. Let's see. So I guess I think what is the term, like the Cartesian separation of you apart from the world. I guess that could theoretically come up with the brains, or it could come up with the AI itself. Let's see. I'm not sure. Yeah. I mean, in a later stage, one thing I do want to eventually get to is things where this stuff might come up more. Like I think that meta-semantics and meta-ethics is actually that actually gives you most of meta-philosophy. So theoretically, I think I should be able to use the resources that I built to do some kind of verification or validation of the philosophical process that led to the creation of the AI. And then in that case, you probably would run into these worries with self-reference, and there the AI would be modeling itself in the world and as being caused by some causal process from the brains, and trying to check, did they make the right philosophical decisions? So all of this is still very speculative and hand wavy, but that's where I imagine some of these issues might come in. As it is now, I don't think I've had to had the AI model itself anywhere in here. It's just modeling the brains, figuring out what they value, and aggregating those values. I don't think I had to have the AI talk about itself in the world. So maybe yeah, maybe it's just ambiguous of, or yeah, I guess it's ambiguous whether it does have a model of itself in the world.
Okay. Stuart, could you?
Yes. So on the sorry, I'm having difficulty remembering exactly. On the when you were constructing the models there, and were the different weighting of the yes, the main point is just quite simply that most humans are not philosophers, and so we have not constructed higher order preferences or meta preferences. We've especially not constructed meta preferences for saying that a weak first order, in the vague sense, a weak object level preference should a strong object level one should overrule a weaker.
Well, okay, so certainly they haven't regimented their vocabulary to articulate these sorts of things as much as philosophers have. I'm not so sure that they lack these things though.
Well, what I was going to get to is, well, I don't know to the extent, is what about someone who has not yet considered the problem, but would have one solution if they did consider it? And the second one is, what if someone who has not considered the problem and could get one of two solutions depending on which arguments they read first? Both of these are cases that are quite likely to happen. So would you say that their meta preferences there are undefined, or?
Yeah, well, that's exactly the sort of thing that that this stuff in the appendix was supposed to alleviate. So that would be there would be different continuations of the agent. One of them hears one argument, another hears a different argument. And then as long as they're both satisfying the decision criteria equally, then they might just be on equal footing when you apply the social welfare function between them to aggregate their functions.
So are you saying that ones that are not yet defined can preferences that are not yet defined but that could come up are also included in the set of preferences to consider?
Let's see. I mean, I think that's how I would like it to work. I think I did run into some technical issues, but certainly at the very least, changes to existing preferences that might come up depending on different inputs. Those are going to be accommodated in my model. Did that make sense? If you're having new preferences with new symbols that the original agent didn't use, that's actually one place where my model doesn't exactly do well.
Okay.
But as long as it's using the same vocabulary of the original agent, and it's just changing how much, for instance, it's valuing things, or it could even be a new preference in the sense that the original agent was able to represent these outcomes fine. It was totally indifferent, but now you could have a new preference among something that the original agent was at least able to represent. And then you can have a new preference on something that they were previously indifferent to. So all of those types of changes would be accommodated by this.
Okay. Well, I think this connects with my first point about new environments. So we can sort of bunch them all together as what happens when there are new symbols. And both when it's predictable that the person will always interpret the new symbols this way under any realistic introduction to the subject, and the situations where they can interpret the new symbols in multiple different ways.
Yeah. Yeah, I'm trying to think how big of a problem it was.
I mean, you don't have to solve everything right now.
Yeah. I'm just trying to think: is it like a big problem, a medium problem? So within my model, I think the problem was because. So think of that last step where I'm translating translating rational utility functions from language of thought to external world states. Then if I was going to try to accommodate these new symbols in this other possible world, are these things going to be separate from the causal model of the world? Or I guess they should still be possible from within the AI's world. So maybe as long as you could still translate them into external world states, they might have to be like merely possible external world states or something. Then maybe it could still work. But it gets into like weird metaphysical issues of how to align this stuff. And then yeah, there was another part that I was a little unsure on, but that kind of ties into this is the philosophical purist in me wants to say my values are grounded in my brain. So if you took my brain and put it in different circumstances, I kind of want to say I have the same values. So then when so one thing we could do is put in a probability distribution over worlds that my brain could be in, but then this probability distribution is ending up influencing the continuations, and so the philosophical purist in me didn't want that happening. So I talk instead about just like all possible inputs, but making sure that we kind of get rid of the ones that just introduce non-cognitive changes, like changes that don't come about from reasoning about your higher order preferences are going to end up getting very low weight. So I don't know, that philosophical purism does create a little bit extra difficulty here, and I'm not entirely sure whether to give it up.
I personally recommend giving it up. It's because if it's true, you'll find it out anyway, and if it isn't, it'll be an obstacle in the design. I'd recommend hacking together something that kind of works and then improving on it. And if sort of purism or more realism or something like that turns out to work, then it should naturally emerge in that context. But if it doesn't work and you try and impose it, then there's something might break. And that's just my my advice there.
Yeah.
Over to you, Søren.
Yes. One of the things that came up in the reading group was this MetaEthical is written in ZLX, which is somewhat of a niche programming language, and if counterfactually this was written in Python, there is a sense that maybe you would have gotten more engagement out of it. Also, it seems like the code seems to be optimized quite a bit for correctness in that with the tests and everything, and maybe optimizing for readability would have been a better choice, like with longer variable names and things like that. Would it be worthwhile to rewrite in Python?
Yeah. I don't know if I would move to Python, but I am sympathetic to possibly porting it to a different language. Probably something like Haskell would be one that I'd be leaning the most towards, because I did want to maybe keep it in a form where in a programming language that has clear denotational semantics. I guess my original idea was something like, once I have it written up in set theory, then maybe it wouldn't take too much to then just write it in standard mathematical notation using LaTeX for humans to read, right? Or if I wanted to continue with the machine readable and executable, which I do like, then maybe switching to something like Haskell, where Haskell is also pretty niche, but certainly there's many more Haskell programmers than set-elect programmers. Yeah, so if I had infinite time, there's definitely many things I could be doing. Yeah, I guess I chose set-LX because it had the clear denotational semantics, and I can imagine translating it into LaTeX later on. And it just seemed a little less overhead than writing in Haskell. So yeah, I mean, if I had written it in Haskell, I don't know, would it have been worth it to write it in Haskell if it would then take me longer to release, right? Those were the sort of calculations that I had. Yeah.
Back to me?
Sure.
So you were talking about diachronic coherence and other rationality and coherence requirements. I'd suggest that some of these coherence requirements are actually themselves more akin to meta preferences than to requirements. The kind of thing that I'm thinking of is, for instance, temporal coherence. Like whether you, like at some point, people enjoy eating, they enjoy eating stuff when they're hungry, and they don't enjoy eating it when they're full. We've decreed that this is not a temporal inconsistency for the reason that, yeah, and there are other things where our desires go up and down. Sometimes we want to watch romantic movies. Sometimes we want to watch tragedies. Our desires and preferences in these areas fluctuate. And we still think that we have an underlying coherence despite all that, because we sort of, but other things we decree that we do have temporal incoherences, like when we overeat and we don't, and then we purge, or we contact an ex that we really shouldn't, and then, but to pick a more narrow example, if someone has a peak of sexual desire and sleeps with someone at that point, this is appropriate. This is fine. This is not an inconsistency. If someone has a peak of sexual desire and calls an X inappropriately at that point, this is a bad decision. So the impact of sex, I should choose a better example, but that's the one that sort of sprang to mind, can be seen as both positive and negative. Sorry, not positive and negative, as time consistent and not time consistent, depending on how we see it. And the way we see it is from our meta preferences. I apologize, but the things are not fully worked out. But a lot of things like consistency, there's the Allais paradox. People that violate various Dutch book arguments and lotteries and other things, but they can say that people buy extended warranties for things, and you can easily check you lose money. There's no, overall, if you buy extended warranties for things, you lose money. If you don't, you're better off. Much better. If something breaks, pay for it. And that'll be much cheaper over the long term. But some people value the security that the extended warranty gives them. Now, that feeling of security, you could say it's an irrationality, or you could say that it is a consistent preference or meta-preference that they are satisfying. So what I'm suggesting is that a lot of the coherence things can be seen as our own meta-preferences and not meta-preferences that everyone would have in the same way and to the same extent.
Let's see. Okay, so some of your examples, yeah, I think it's sort of like when you just describe, say, the peak of sexual interest, it could be good or bad depending on the surrounding context, right? So
it was more that have sex when your sexual desire is the highest is a perfectly rational and recommended course of action. Call up your ex that you've had a difficult relationship with when your peak of sexual desire is at its top is incoherent and probably predictably going to lead to mistakes.
Mm-hmm. Yeah, so I don't know. So
not
some
the best
of this
example. I should find it.
Okay.
But yeah, the basic idea is that the same, say, fluctuating background thing can in some case be seen as part of a single preference function, i.e. have sex when it is most enjoyable, or as a source of irrationality.
Yeah. It reminds me of one response to the Dutch book might be to say it's actually fine, and you build into your preference that I if they're leading me into a circle, I'm paying $5 to go from A to B and from B to C and to go from C to A. If you build enough context in and say, even in the move from C to A, I just value moving to A after having paid $5 and $10 to move the other two times.
Mm-hmm.
If all of that can be in your preference, you could actually make it like a coherent utility function, a rational utility function. It seems pretty implausible that anyone is actually valuing things like that, but kind of reminded me of that. But I don't know. Some of these issues seem more about how we just capture things within a single utility function, like how context sensitive is our utility function.
Mm-hmm. It's as I say, I'm more just prodding at the various things.
Yeah.
Seeing how they work, seeing how you would.
Yeah. So the actual for utility functions, I did want to get a little bit of psychological plausibility, because if you had to represent utility functions as specifying utilities for every single possible state, that's certainly not, we are not some giant lookup table with a list of every possible state, right? So I ended up using like an additive utility function. So given some state, if you figure out how many of the formulas that you place utility in make it true, and you add up the associated utilities. So this would allow for maybe you value P, so you put some utility on the formula P being true, and then you have another formula P and Q, and then you could place a different utility on P and Q, and then I think that'll actually add up, because both P and Q are true, then those will add up to whatever. So maybe you generally like when proposition P is true, but if Q is around, then you don't like it, right? So maybe you place 5 utility in having P, but then negative 5 if you have Q. So then if P and Q, then you're just indifferent. So those are some of the things that you could do with my current model, and certainly there's probably further ways to make these more realistic and context dependent. But I think it's a fair amount of that is allowed by just the additive utility functions that I have. And in the limit case, you could just add in that such that it behaves again like that giant lookup table of all possible states. But if there are places where you need to get more fine-grained, it does allow a fair bit of that already. But I'm sure there's also further improvements to make. But that did seem a little bit different from maybe some of the measures of synchronic and diachronic coherence. I think that's actually mostly in where I work out agential identity. I didn't know if this is where you wanted to go with it, but this was supposed to be some measure when you're running the continuations of an agent. If this is supposed to measure how much you're the same agent or not, and it kind of included this.
Excellent. This is the sort of thing that I've come to think about recently, and you seem to be ahead of me there. The agential identity is the. Oh no! I'll come back. I'll let Soren bring in a question.
Okay. So one of the parts of the way that the utility function is constructed seems to be almost equivalent to simulating putting human brains in different situations. And given that it seems we're trying basically all states that the universe can be in, it's possible that we are implementing, in fact, not just mind crimes, but every possible mind crime. Do you agree?
Yeah, certainly. If you just naively, if you found a computer that has infinite computational power, and you ran this algorithm inside of it, then yeah. Well, first it'll probably crash because there's tons of bugs. But if you could fix all the bugs and have it run, then yeah, there would probably be tons of mind crime. So this isn't. I'm not suggesting that anyone actually just fix the bugs and then run it, because that would be a big concern. The hope would be that somehow a lot of what I'm trying to do here is kind of define the ground truth for the value functions, and I'm not imagining that this would by any means be the actual algorithmic procedure that the AI uses, right? maybe maybe it's, but I do feel like it can be important to have this defined somewhere in the AI so that it kind of knows what is the ground truth. So some of these other proposals, which I'm sympathetic to, like maybe like trying to get at our preferences via debate and things of that sort, or some of the amplification stuff. I do feel like those would be probably closer to what we might in the near future do in building up some kind of data set from which we try to infer what people's higher order preferences are. So presumably you could do things like that without without doing mind crimes on these people you're simulating in your finite human brain. So it might be that when you scale this down to run with actual finite power, that you want to do a lot of that stuff. But I do kind of think it is important that there be some recognition that basically I don't think we want to define the ground truth in terms of what comes out of those types of things. I think I guess I have some worries there. So I kind of like if the AI could have these concepts, then maybe it could even take over creating new iterations of what are the best methods that would actually be finite approximable to this. But it kind of needs some definition of this to know what is finitely approximating. And then of course, as we're doing the approximations, we also want to make sure that we're not having it commit mind crimes as well.
Thank you.
Okay. So suppose that someone writes a psychological paper or a philosophical paper that is relevant to sorting out people's preferences. How, if your AI has been launched already, how do you imagine it taking into account this innovation? Because one of the biggest difficulties that I have is to know how much has to be put in by hand and how much doesn't. That's why I've been looking at things like diachronic consistency. Is this in the human head so we can delegate it to preferences, or is it something that we just want to impose from outside? So similarly, so someone comes up with a paper about psychology that illuminates some aspects of human preferences. And this thing, for argument's sake, or a philosophical thought experiment, and we'll assume that this is relevant for this. How would the AI in this take that into account if this happened during its run?
So let's see.
Or I mean, or you can have it published beforehand if you want.
Yeah.
How would it take this data that is already out there that is relevant but not in an AI parsable form?
Let's see. So I guess it kind of depends. So is there a mechanism that it's positing about how our preferences work? Is like the content of that paper?
Well, let's say it's the anchoring bias paper.
Okay.
It's pointing out a particular bias that
so
people didn't really realize was there before, but now they realize it's there and they agree, yeah, this is a bad bias, this is not a preference.
Yeah.
Before this anchoring bias was not known, and we'll presume that we haven't put enough for it to identify the anchoring bias from other principles. But someone writes this paper, and there's a few people who agree in the world, oh yes, that's a good idea. So, but how would this enter the algorithm as a data?
So I mean, the current version doesn't really work off of data like that, right? The current version is just assuming you have a low-level causal model of people's brains, and that's where they're getting the data. But we could talk about maybe what adjustments should be made to this algorithm when you discover a paper like that. And I do want in the future to have the AI maybe have some self-modification abilities. So maybe we're talking about like some future iteration where it has some of those abilities to kind of take info from a new paper and try to integrate it with other information.
You wouldn't want it. You wouldn't want to hand specify. Take this paper or papers on this archive or thing. You'd want it to be able to take that kind of data, understand it, and like it might be a conversation between two top philosophers that is relevant for novel situations or something.
Yeah, I mean, for something like the rationality scoring metric, right? You can make some adjustments, like so. In general, we apply a principle of charity, but if we know for a fact that humans are very prone to an anchoring bias, maybe we don't penalize attributing anchoring bias as much as if it didn't fit some known pattern, right? So that would be an example of some way you could change some of the scoring mechanisms here.
Yeah, but that's doing it by hand.
Yeah. So that's why it's not directly applicable to this version, but maybe you wanted to talk about some future version.
Okay. These are some of the things I'm suggesting are things to bear in mind, possibly.
Yeah.
And okay, I think I have three more questions / comments. Yeah. So over to the audience.
Well, I think I said an hour and a half to June and you.
Okay.
So and we are close to the 1.5 hour mark now. So if June, if you need to leave or anything, then please feel free. But otherwise, I think we should give Stuart's questions priority towards the end.
Yeah, I'm able to stay.
Okay. So the first one is, do you have a population ethics or a way of solving that issue?
I guess I would file that under normative ethics, as opposed to meta-ethics. I mean,
the reason I ask is because you are getting the preferences from brains. This is a certain population of brains that could be variable. So how are you going to deal with the issue of variable numbers of brains being created or destroyed?
Oh, I see. Yeah, so I guess in terms of what I've coded here, I think I was trying to just simplify it into just take all the adult human brains at the point in time in which we're wondering whether to press the button to let the AI go, and that presumably if it's able to get the values that these humans should have, and if these humans should value future generations, then you should get the result just by scanning the existing humans' brains. You should get the result that it should value future humans.
Okay, so this I'm putting in the category of delegating to current human preferences to resolve. Yeah.
Yeah, current human preferences, but idealized, right?
Yeah. But yeah, that is that's the way I tend to go for a lot of these things, like especially issues of identity. But the other thing is, have you thought of a potential error detection layer, or as in something that a lot of our beliefs about human preferences and humans in general are expressed in your algorithm, but we have some judgments as this outcome is terrible or this outcome is stupid that are hard to capture in this preference formalism and could be more captured as error checking. I was wondering if if you consider that this might be a way to go, or some sort of catching disastrous errors.
Yeah. I mean, certainly for anything this abstract, you would definitely want as much testing as possible to validate it. I mean, I don't know how far I've gotten in actually working out how you would go about doing it, but I do think that there should be plenty of that if this was going to be ever close to production.
Okay. I'm looking forward to that.
Yeah, I have thought a little bit of like, say, like a shutdown button. Going back to the idea that a lot of meta philosophy is meta ethics, or can be answered by meta ethics plus meta semantics. So could you do something like scan to take people's brains and figure out what their concept of ethics is, or what concept of theirs that's closest to this meta ethics is. Does it play the same role in their deliberations? And then try to apply it to the whole algorithm and kind of ask everybody with their fate. If we have a way of figuring out what the concept of ethics various people have, does it actually match up with the meta ethics that's been programmed into this?
Well, I was more sort of thinking along the lines of some form of compressed, accurate summary of where the AI wants to go.
Oh, yeah.
The checking that humans are not totally repulsed by that.
Mm-hmm. This would have been sort of a separate thing along the same lines.
I've sent you a somewhat silly example there where I imagined a problem with CV. And there the problem is that it follows the coherent extrapolated volitions things at every step, arguably, but ends up in a terrible place.
Yeah.
And a lot of what you're doing seems as if there might be, you could just think of sort of ultra Buddhist that ends up destroying the world, kind of through altruism. But it's hard to tell because of some of it depends on some of how you interpret distance between various utility functions and idealization processes. But it seems that it may be vulnerable to things like that, series of rational seeming steps that end up in a very bad location, and some sort of checking or overall connection with the initial starting point might be something worth thinking about.
Yeah. I mean, I guess my theory is supposed to be able to capture pretty much any normative reasoning that humans do. So if you're able to write up this example and use it in an argument about what we should value, then theoretically, my model should capture what's going on when you're doing that. You have some criteria that you're subjecting your values to, and then we should be able to tell if that criteria is being applied correctly or not, and that would
This sort of thing. Sorry, okay,
so
that's what you're saying.
yeah. So basically, if you're right that there is an argument here to I don't know, beware of, is it fair to say, like a chain of transitive normative reasoning? Oh yeah, I don't know how to summarize this very quickly, but if this constitutes an argument about how we should interpret our values, then within my model that should be capturable within some higher order decision criteria that we could then apply to get the result that you want.
This is something that could be tested to some extent empirically, because your process is imagining idealized versions of humans, and a question is this unstable or is this a stable construction? And if sort of meta-normed arguments like this are included and have a strong effect, I'd expect a more stable outcome where shifting around minor preferences don't make much difference. But if it's unstable, then it could go in many, could end up in many areas.
Yeah. I mean, I guess my model right now is probably going to be agnostic on exactly how you specify the sort of initial conditions, how you fill in what the content of people's preferences are. So probably there are some ways of making it stable and some ways of making it not stable. And that would be really good to know what sorts of features in general make it stable or not. There is also, I haven't been following it as closely because I'm not really in academic philosophy technically anymore, but there's been interesting work in experimental philosophy where their whole idea is philosophers talk all the time about, oh, people have this intuition or that intuition, using those in their arguments. They want to go out and actually test, do people have those intuitions? How much do they have them? Is there diversity in the people who have them? And I saw a paper, I haven't had a chance to read the paper, but just skimming it a little bit, it looked like that paper was finding that there actually are a lot of like universalities in not necessarily like in the end answers that they give, but in the types of intuitions that they bring up, or it might be that there's research showing that you could frame the problem in certain ways to get them to go one direction, frame the problem in a different way to get them to go the other direction, but that this susceptibility to the framing seems to be kind of universal. So I don't know. There's been some intriguing research that suggests that there might be a lot of overlap within humans when it comes to ethical decision criteria, and that would certainly be better. I mean, I think my model can work even if that's not true, even if you think that there is much more diversity. But I do think that it's a little bit easier if for the most part there is broad overlap in what the content of these higher order norms are for actual humans.
I agree with you, and I think there is quite a lot of overlap between humans as well.
Oh, that's good to hear.
And I just want to sort of, okay, I'll try and keep this brief. So part of what I was thinking of why there was tests is to distinguish moral systems that are defined by a stopping point, by stopping conditions, from those that are constructive from the basis. So if you if you want to have sort of coherence, rational coherence between your preferences and meta preferences, you can either do this sort of building up, or you can sort of do it until you get to a point where coherence has been reached. And the do it until, and CV is sort of an example of do it until the conditions are reached. And the do it until things seem to me very dangerous, because this might do a random walk across all ethics, because all that it really cares about is the stopping conditions. So that means that there are certain attractors in ethical spaces, and when it hits one of them, it stays there, but we don't know if it's going to hit any one of them, any good one early, and it might miss them all and go out for something bad or simple.
Yeah.
Whereas the ones that are, when I was talking about checking from the original thing to the end, I was sort of saying ensure that there is not too much of a distance, in a sense. So ensure that it's constrained to build up rather than just wandering from this starting point until something happens.
Yeah, yeah, and I do model some of that. I look at sort of a chain of agential identity between each continuation over a whole path, and we kind of want to ensure like not just that the beginning and end have decently high agent identity scores, but also that maybe nowhere in the chain was it below a certain threshold. And then I also wrote some notes to myself in the code of like I think I probably had a very crude stopping point, like just stop at time 10 million or whatever. But obviously I'd like to get a more principled one. Like, is there some way where we could kind of ask these agents, are you at a stopping point? You know, it seems like something like that might be the best way, but I just didn't want to get into that complication for this version.
I mean, ask the agent, are we at a stopping point? Seems like continue until this condition is reached. Anyway, so I was wondering if we could talk more about this at some point, maybe next week.
Oh yeah, that'd be great.
Cool. We'll sort that out when when other people.
Yeah.
The other thing is that I would encourage you to try and write it out, a lot of the ideas written, and not just in the algorithmic form.
Yeah.
Mainly because I found it so useful myself to have to formulate my ideas in written form and try and get other people to understand them, no matter how imperfect I am at that. This tends to clarify a lot of things when you do the process. And apart from thanks for your talk.
Oh, cool. Yeah, I appreciate you being here.
I would also like to say thank you very much, June, for joining us today. It's been a pleasure, and I certainly learned a lot, and I think everybody here has really enjoyed both the discussion and your presentation.
Awesome.